Hello guys, welcome to my workbench again on part 3 of our tube or valve tester. As you can see, I made the box with the rondzee. I made that, as you saw in the video before, I put everything in place. You can see this meter I replaced because the other one meter had a diode inside, so I couldn't shunt that meter. I can't shunt that one, so that will be okay. See what else did I do different? I replaced those two potentiometers because I had other ideas, so that's the reason why. I will show you on the bottom what I've done. You can see it here, so let's have a look in the camera. What you can see. There's not a lot, is it? So see if I can drop it down a little bit. Hold on. Drop it down a little bit. So sorry about the earthquake. There we go. I hit up. There we go. So well, you can see the wiring. Hopefully. Yeah, so I have to tilt it a little bit so you can see it properly. Hold on, so there we go. I think it should be okay now. Anyway, you can see on the bottom what I've done, so everything is wired up. All the top is wired up. I made that meter suitable for 10 milliamps and 100 milliamps. That's what we have to measure. I had those meters also done, so that should be alright. So I put those potentiometers, I told you, I put them in with resistors, what is necessary. The only thing what I've done is to move the filaments. I moved that up to the wet wire, so they're on the top. The next one is then the G1, the first grid. Then we have G2, and then we have the anode. So I put that out of the way because if you want to test some triodes, then the filament indication is in the way, so it has to be on the top, so it'll be out of the way. So that's what I've done. So the only thing we have to do now next is to get that transformer in order. So I made some calculations. We have 235 voltage on the net, so that will be 1739 turns on the primary, and we need about 260 volts secondary, that will be 1920 turns, and the maximum voltage for the filaments is 18.5 volts. That will be 133 turns, and we have another 10 volts for our negative voltage for our grid. So that will be 74 turns. And the transformer has about 7.4 turns per volt. So there's only a small transformer will be placed in here on this side, will be okay. Then we have to make two MOSFET power supplies, one for our anode and one for our screen grid. And then we have another stabilizing power supply from 10 volts to supply us with the negative. So hold on, to supply us with the negative voltage on this switch. So that will be 6 volts. We step in higher, 10 volts, so it should be okay. Then we can turn that back to 6 volt exactly, and it will be stabilized, so there's nothing wrong. We can turn the polarity around, so it will be negative. That's guys, that is about the story at the moment. So I'm starting off our transformer. I will turn the camera around a bit so you can see it. Hold on. I'll turn them around now. And there you go. Yeah, okay, hold on. Now it is okay. Now he's in the starting blocks as it were. So I will start it off now. Switch that on. Yeah. And put the door out of the way. There we go. There we go. And that's the primary, guys, we have to do now, and that's what the thing is about. So I will come back to you when I have more, okay? Hi everybody, welcome back to my workbench. As you can see, I have finished the transformer. He's on the workbench, and I put the voltage on there. You can see that 232 volts. I need for the valve test, I need about 250 volts. There you go, 255 volts. Now then, I have also a negative voltage necessary from 6 volts. I put the winding on here. That gives me about 14 volts. Yeah, so I can use a normal regulated power supply. So with a 1 amp chip or something like that. And then I can regulate that back to 6 volts. It will be constant 6 volts. Okay, so if necessary I can increase the voltage if necessary, if it would be necessary. Furthermore, I have to make for the filaments 5 volts. I thought 4 volts, but I had to look it up. 4 volts is not necessary, so 5 volts should be okay. Then we have 6.3 volts, we have 12.6 and 18.5 volts. So I'm going to measure this now. This should be 5. Well, I took the meter. Take the meter down a bit. There we go. That's one tap of it. That gives me about nearly 5 volts. That is okay, because if you're using on 4 volts, you have 4.5 volts, so this should be okay for 4.5 volts also. So then we have 6.3. Now that's 6 volts, that's okay. Then we have 12 volts, and we have 18 volts. Nearly, so I can adjust it a bit, so we get up to 135 volts. Have a look. Yes, that's 235, so I should measure this voltage again. Nearly 258. That's okay. Then we go down in the voltage and we checked. This is 15 volts. Yeah, nearly. That's okay, that's fine. Then we check that again. Yeah, that should be okay with 5 volts. 6.5, 6.3, that should be alright. Yeah. See, we're not going to complain about a couple of tenths of volts. That should be okay. There you can see 18 volts, yes, okay. So yeah, all considering all the efforts, we have a perfect transformer. So it should be okay. We could rectify this also, if you think about it. We could rectify this, and then we could increase the voltage as well. So if it came to it, if you would rectify it and put in a capacitor between it, then it will give you a couple of volts more. So come on. There you go. There you are, guys. We have our transformer here with the tabs underneath. So it took me about a day to get them done. So that's so far so good, guys. So we'll come back to you. I have more, right? Hello, guys. Welcome to my workbench again. So I've made my power supplies on print. You can see that in front of you. We have here, I have the screen grid, the anode, and we have G1, the 6 volt grid voltage. Have here. The only thing we have to do here is to put on the rectifier, and that will be it. I have to do some work on the back still, but I will do that. Then I can position it in there, the rectifier and the capacitor for this set will be fitted on the transformer. I will show you that later, right? The next thing I want to show you is our hold on, I should pre-position the camera a bit. Let's have a look. There we go. Now let's see if we can focus that bit. There we go. Okay, sorry about that, guys. What I've done on the back is put this 2 meters in parallel. Yeah, and it's connected up to our meter for the current. So all microamps, as you can see, but you have to read this as voltage. 500 volt, 500 volt, and this is 100 milliamps or 10 milliamps. So, and it was controlled by this switch. They're now standing on 100 milliamps. I put a resistor as how do you call that? To draw the current. So I put 100 milliamps. I put them back on 10 milliamps because 100k is quite a lot. So I put on the switch from the power supply now, and you can see the lowest what my power supply can go is 110, 120 volts. That's where it is. Yeah, and you can see on the current as well is flowing. Yeah, I put them up to 300 volts. That's about, yeah, it is a bit over, you see that? That's because of the resistor. Yeah, put back a bit, there you go. Yeah, it's nearly there, it's both the same. So a bit over, he's a bit over there as well, so that's 300, so that's about 300, so this correct. You can see the milliamps is drawn for 100k. You can do the math to get the result of 3 milliamps. So this is connected to 3 milliamps or 10 milliamps. So I'll put it back. You can see it goes back. I won't do the other stands because it goes on 100 microamps and it will be bang and it will be in the corner. So you can see what I've done. So you see both meters are working at 300 volts. You can see that. It's even higher than that. on my power supply also, so I put them now exactly in. There's some tolerances, yeah. I think that's because of the resistors, the tolerances in the resistors, but it doesn't really matter. It's a bit higher. The only benefit of that is because it's a bit higher, you don't go over the voltage, it's almost 250 volts like that for a valve. That's about it. So you can see it's okay. You can see that here. This is the screen grid and the anode. The only thing you have to plug in the valve and the socket you need. And you can switch your voltage, your filament voltage, you can put that in order, put the scale on there as well. So, and then we have here our 10 volts or 6 volts switch to get the negative voltage on your valve. So, but you can see it works. I didn't complete it yet, so you can see if I go down on the voltage, the current will drop as well. So put it on 150 volts, something like that. There you go. Should be half of the current what's flowing through it. So yeah, I can put the 10k in there to put the load on there, but the load is represented by the resistor. Normally that will be the valve. So that's all there is to it, guys. So so far so good. I will stop the video again. Excuse me. I will finish my little print here and finish my transformer with all the wires and whatever and all the trimmings, and I'll come back to you. Okay. Welcome back, guys, to my bear bench again. As you can see, well, you can see the thing is finished. I connected everything up. So let's put the resistor back here. That's it. Okay, so I had to make some adjustments. I had to change that round because it was turned the wrong way round. So I changed the connections so that it will be correct. I've made my power supply complete. So these are this is the anode. No, this one is the anode and this one is screen grid. And this is the direct connection to the transformer, to the power supply. So I have the two connections, two resistors to the potentiometers or the VRs. Yeah, it's about time for testing. The only thing I have to do now is to put the plug on. So that's the thing I have to do. With this video's quite long already, so I will reserve that for the last video. Then we go through the testing together. So we will test then the voltmeters, see what if they should be individual, they should be working. So that it will also be. It will be separately working. What I've done here, I make a bridge on there, as I told you in the video before. Made a bridge here on this print. Connected them up to these two point on transformers, 14 for 15 volts. So we have a little VR here and for adjusting the voltage up to 6 volts. So there will be no current, nearly no current. There's an LM314 was put in there. These are two MOSFETs capable of delivering 15 amps. So it's 100 milliamps, so there's only 4 milliamps. This is 100 milliamps, this is 4 milliamps. So they won't heat up, so you don't need any cooling on here. So yeah, that's about it, guys. And then the next step we have to do when we discover it works, then we can turn this round. we have to sticker the whole, let's have a look if you can see it. Yeah, we have to sticker all those 10 knobs, we have to sticker them. So we have the first is nil, the first is the entrance, the G1, the grid, the first grid. Then we have the screen grid, and then we have the anode, and then the filament. So we have several stances in here. So every socket that we have on here is pin 1 on all of the sockets, pin 2 on all of the sockets, pin 3 on all of the sockets, pin 4 on all of the sockets. You get me? Then I put on here a separate for banana, as we call the banana connection, with a crocodile to go to a top connection of a valve. Normally the most of the top connections on valves are on the octal socket. So I put them in the vicinity of the octal socket, and I put them in the vicinity of this P socket. So I didn't come across one of them. There's a 10 pin socket, a top on there. So I didn't see that yet, so perhaps it's me. We have also top connections on the novel socket. On those we have none. So some valves, I think that they are diodes. They have the high voltage diodes. By the way, you can't measure diodes with this tester. You can't do that because you would short the valve and you would burn up. So you can't do that. What we can do is pentodes and sets. RF pentodes, and we can do pentagrids. We can measure them, triodes, we can do that, all that, but I honestly don't know if we can measure this eye, for instance. I don't know if that will work, so I have to find out. I have a hunch it would work, but I don't know which one this is. All the text is gone on the valve, so I have to look it up. There's a P connection, so I have to look it up what kind of valve this is. I don't know if it is any good. I don't know. So we'll try to find out what kind of valve this is, and he will fit in here nicely. So and then we can see if he will work, yes or no. For instance, I have here an AZ41. You can't test that on there. It's impossible because you would short the valve and it would blow up. So you can do that with the other valve tester. You see if you can see if the emission is okay. So, but if you have to do this, you have to very low voltage. I will have a try, but the cathode is straight to ground. So you would short the valve out. So you wouldn't do that if I were you. Yeah, that's about it, guys. You have a power switch here. To the left is off and to the right is on. So we have a double switch for the null and the phase, the plus and the negative of our net feed. So I did that double because I don't want to have any voltage, no matter how you turn that plug you have on both sides. You could have high voltage, and you don't want that to have on here because of the sensitivity what you are doing. So you could electrocute yourself if you would be on the back of this. The possibility that you electrocute yourself is quite possible, so that's why I made a double switch. So okay, let's have a look. When I come back to you with the other video, then we will test the meters. We test the screen grid, we will test the anode, and we will test the current from this meter. This meter and this meter is connected to each other. So We can see, for instance, if a valve will light up, we can see that as well. And then we have to connect them up. And we have the booklet here. Let's have a look, there's no booklet. We have the booklet here, so we have the tube. So we have here the RF. So let us take the EF41. Then you will find your G1 is number 6, your G2 is number 5, and your anode is number 2. So yes, so if I have to have 6, that's this one, I have to put them on the first arm, that's G1, okay? Then we have 5, that's that one, and then put that on screen grid, so there's 1, 2, that's screen grid, and then we have 2, that's this one, you have to go screen grid, anode, yeah, and we have to have our filament, that's 1. Then we will be set up for EF41. We have here in the corner, we have the amplifying factor. It's 2.2 milliamp per volt. So the negative voltage is here from 2.5 to 39 volts, negative. So we have to find out with our switch here, which so that we will begin on 1 volt, 1.5, 2, 2.5, 3, 3.5, 4. So that I would put it on 4, so that we can see what happens when we increase our voltage here and here. What happens, we can see the current. The only thing you have to look for is that you don't exceed the current that has to flow through the valve. So that is about 1.7 milliamps. So we have to put him on 10 milliamps. So the scale will read 10 milliamps. So 1.4, what is this? Have a look. 1.7. So should be nearly the deflection should be near the 1.8, something like that, in between there. So you can see that. The only thing you have to look for that you don't exceed the current, because you have no resistor on the cathode. It's straight to ground, so we have no protection for the valve. So the maximum current can flow. So you have to be careful how high you put up the voltage. The current should be on 1.7. Then you can adjust one up, one down. So one up, then the current will go down, go one down, the current will go up. And the difference between those two is that number what is up there. So 2.2. That should tell you what it should be. Anyway, that's what I believe. As you say, the problem here, because there's 2.2 milliamps. It could be possible you can read it anyway. So if I put up a lower negative voltage on there, then the current should be flowing up 2.2, let's say near to 3 milliamps, and then go up with the negative voltage, it should drop down. So the difference between those two should be 2.2 milliamps. That's what I presume. So if I'm wrong, I'm wrong. So that's how I understand this, how this is working. So anyway, I will check my my courses, as such quite involved. I will read up on that one, so to refresh my my memory, so that I don't have that wrong. So that I have to have the right view how to test those valves. So they don't. You can test a valve. You also can wreck a valve. So that's something we don't want to do. Anyway, guys, I think it should be working. It should be working perfectly, actually, because according to the schematic. Let's have the schematic. Then we have the schematic. Let's see if we can enlarge this a little bit. Let's have a look. Okay, we'll go closer. And it is overexposed, so you can't see it on. A little bit darker, guys. So, and we'll refocus. Hopefully it will refocus. Yeah, I'll refocus. Okay, guys, my camera went down. Put a new battery in it. So anyway, to proceed what we're doing. So we can see here our valve. We can see here our voltmeters. Yeah, that's the anode, that's it, that's the screen grid. You can see the VR where it is all regulated from. So we can potentiometer or VR as you call it. We can see here the power supply. We don't use that, we use our MOSFETs for that, because we probably don't need our choke, because our MOSFET, so we have to see how that works. If I have to choke if need be, so I can't put them in. You also can see here how this is done for the negative voltage with our attenuator here with our 12 10k resistors. So anyway, again we have our voltage regulators, the LM317 I thought it was. I put in, so we don't need this all. There's even a stabilizer here. It's on 7 volts, so we have here our VR to put them on 6 volts exactly. Anyway, guys, that's about it. Yeah, there's not much to tell, is there? That's how they made that up. That's in 1967, I think. This booklet is. So yeah, that's how I understand. That's what they tell me here in the text. How this thing is working. So that's the point where I started from. So that's why my understanding is how this works. So anyway, so I have to see what that will be doing, because we have no resistor at all in this cathode. So it's straight to ground, so the maximum current can flow. So you have to be careful when you have your book that you don't exceed your maximum current in your anode. So you burn up the valve, so you wouldn't want to do that. Anyway, guys, that's so far so good. So as I said before, I will go through our testing together. So put my plug on, and the video is quite long at the moment, so I will stop it here and I'll come back to you with a new video. Then we will test our valve tester, and then we will check some valves on their amplifying factor, see what this does. It is actually quite new for me also, because I'm 67 years old, no, 77 years old, say, oh God, I'm cheating, 77 years nearly. It's quite some time ago that I done my study, so it is a bit, now after those times it's a bit foggy. Your age is playing a role as well, so I have to look all things up again, so to refresh my memory. So we don't do anything wrong, but I don't think I'm wrong at all. But there again, you're human and you make mistakes. Anyway, guys, that will be it for now, and I will be happy to see you view my video, my last video. I think that will be inspiring. I hope it will encourage you to build some things yourself. Start out with some easy things, some easy projects you understand, or try to understand, and then yeah, you need to build it up. As I started out when I was 10 years old, and that's 67 years ago, nearly 67 years ago, I started with transistors. So then the valves were very popular in those days, because they were still as usual. The transistors nearly now in the beginning 70s, they started to come up in the markets, and they said, well, the transistors are much better, and blah blah, you name it. And in actual fact, guys, the honest truth, I came across the transceivers in the Second World War, and the only thing was bad that were the resistors and the capacitors. And the valves, believe it or not, they were, and the most of them are in top condition. So, and that's 80 years ago, more than 80 years ago. So it makes you think, what is true on that story from the 70s. I know transistors, they will deteriorate as well after a while. They're like capacitors and so on, because the insulation between those connectors, or my English is not that well. Anyway, you know what I mean. Deteriorates, and like a capacitor, and will go at a certain point, will lose its capability, and it will destruct. So I don't see a transistor survives 80 years, to be honest. Well guys, that will enough chat. I will shall finish the video now, and I will come back to you, okay?